In the spring of 1944, deep inside the heart of Nazi Germany, the Luftwaffe's secret testing units made a discovery that left their brightest engineers in disbelief. Amidst the chaos of losing war, they came into possession of a captured American fighter, the Republic P-47 Thunderbolt. It was a machine unlike anything they had seen before. Beneath its rugged exterior was an engine so powerful, so perfectly balanced, that even Germany's finest minds, the same men who built the Messerschmitts and Focke-Wulfs, realized they had reached their limit. This is the true story of the day German engineers examined the P-47's 2,000 horsepower engine and understood that they could not match it.
The airfield at Rechlin was unusually quiet that morning. The usual drone of German fighters testing their engines was replaced by something else, a heavy, throaty rumble that none of the ground crew recognized. A truck convoy rolled through the mist, flanked by guards. On the trailer sat the battered remains of a large Allied fighter, silver-skinned, its wings scarred, its nose crumpled from a rough landing. The fuselage bore faint traces of white stars on blue, the markings of the United States Air Forces. The captured aircraft was identified as a Republic P-47 Thunderbolt. It had crash-landed in occupied territory after a fuel line failure, its pilot captured alive. The Luftwaffe saw an opportunity they could not waste. Within hours, the damaged fighter was moved to the secret Luftwaffe testing base at Rechlin. This was where new aircraft were pushed to their limits, and where the Luftwaffe's elite engineers studied captured Allied machines under utmost secrecy. The project was placed under the supervision of a special evaluation group known as Zircos Rosarius, a unit devoted to testing enemy aircraft. Their mission? Learn how the Allies built their machines, understand their weaknesses, and, if possible, steal their secrets. As the hangar doors closed behind the P-47, the German engineers gathered around it with notebooks and measuring tools. What they saw both amazed and unsettled them. The Thunderbolt was massive, far larger than any single-engine fighter Germany had produced. It looked more like a small bomber than a fighter. Its huge radial engine dominated the nose, and its airframe seemed overbuilt, almost indestructible. When the engine cowling was removed, the Germans stared in silence. Inside sat the heart of the beast, the Pratt Whitney R-2800 Double Wasp, an 18-cylinder twin-row radial engine capable of producing more than 2,000 horsepower. To German eyes, it looked alien. The layout, the wiring, the precision of the castings, everything was different from their own engineering philosophy. Their top piston engines, like the Daimler-Benz DB605 or the BMW 801, were powerful but delicate, finely tuned like racing engines. The R-2800 was something else entirely, a brute force machine, rugged, simple, yet astonishingly advanced. Over the next several weeks, the Germans disassembled the Thunderbolt piece by piece. Every piston, every valve, every bolt was cataloged, measured, and weighed. Metallurgists scraped samples from the cylinder heads, studied the alloys, and analyzed the heat treatment of the parts. The results were baffling. The Americans had somehow managed to produce an engine that could sustain immense power output for hours without failure, an achievement that eluded even Germany's best designs. The supercharger system, a labyrinth of ducts, intercoolers, and turbines, was far more sophisticated than anything Germany had built for a single-engine fighter. And the more they examined it, the clearer it became. This was not just a powerful engine, it was a masterpiece of industrial design. Every component had been optimized for mass production, yet none sacrificed reliability or performance. By the time the examination was complete, one engineer muttered a quiet truth that none dared say aloud. Even if we copied it perfectly, we could never build it.
After weeks of repairs, the captured P-47 was finally ready to fly again. Painted in German markings, it looked almost unrecognizable, except for its unmistakable bulk. The man chosen to fly it was Oberleutnant Hans Werner Lerche, one of the Luftwaffe's most experienced test pilots. Lerche had flown everything from the nimble Spitfire to the rugged B-17 bomber, all captured during the war. But the P-47 intimidated even him. On the morning of the flight, engineers double-checked every system. Fuel lines were flushed, oil was topped off, and the radial engine was warmed up. When Lerche climbed into the cockpit and hit the starter, the hangar shook with a deep, rolling growl. The engine came alive like a thunderstorm. He taxied to the runway, pushed the throttle forward, and the P-47 surged ahead. Despite its weight, it lifted smoothly, climbing into the sky with effortless stability. At first, Lerche kept the tests simple: straight climbs, level turns, shallow dives. The aircraft felt heavy, but remarkably stable. The controls were steady, the stall behavior gentle. Unlike many German fighters, which demanded constant attention, the P-47 seemed to fly itself. Then came the performance tests. Lerche pushed the throttle wide open and climbed at full power. The airspeed held strong, temperatures stable. Even after long minutes of high boost, the engine refused to overheat. The cooling system, an intricate balance of airflow, cowl flaps, and intercoolers, managed the temperature perfectly. He then dove from altitude, exceeding 500 miles per hour. Most German fighters would begin to shake or compress near that speed, but the Thunderbolt stayed steady, its heavy frame slicing through the air like an arrow. When he pulled out, the structure groaned but held firm. After landing, Lerche stepped out, visibly impressed. "This," he said, "is not an airplane. It is a flying engine with wings attached." The engineers crowded around his flight report. Every metric was beyond their expectations: speed, climb rate, dive recovery, even cockpit comfort. The P-47 was designed to endure, not just perform. In the following weeks, the Germans conducted dozens of test flights. They studied its roll rate, acceleration, and handling under stress. They noted how forgiving it was to fly, something invaluable for mass pilot training. The Thunderbolt could absorb punishment and still bring its pilot home, a luxury few Luftwaffe fighters offered by 1944. But what astonished them most wasn't just its power, it was its endurance. The R-2800 could run at combat power far longer than any German engine before showing signs of wear. Where a BMW 801 might need careful nursing after minutes at full boost, the American engine roared on hour after hour. After each flight, the conclusion grew clearer: Germany had nothing like this. Their own engines were engineering marvels, yes, but they were fragile, temperamental, and reliant on perfect conditions. The P-47's engine was built for war, reliable, powerful, and simple enough to build by the thousands. By late summer 1944, the engineers had stopped talking about copying it. They began to talk about surviving it.
Inside the Rechlin laboratories, the mood turned from curiosity to quiet despair. The German engineers had stripped the P-47 down to its bones, but understanding its brilliance only deepened their frustration. They compared the R-2800's metallurgy with their own. The Americans were using alloys with high nickel and chromium content, metals that Germany could no longer obtain in quantity due to Allied blockades. Their heat treatment processes were precise, their machining flawless, Even their bearings and seals were made from materials Germany hadn't seen in years. The manufacturing tolerances were another revelation. Each cylinder head, piston, and valve seat fit together with microscopic precision. Mass production had not dulled American quality. It had perfected it. One engineer remarked bitterly, "They build thousands of these, and every one runs like a watch. We hand-build ours, and half break before the front." Meanwhile, test comparisons continued. The Germans measured the P-47's acceleration against the Focke-Wulf FW-190, one of their best fighters. At low altitudes, the German aircraft could still outturn and outclimb the P-47 in short bursts. But above 20,000 feet, the American supercharger made all the difference. The Thunderbolt kept climbing, while the FW-190 gasped for air. The reports from the Eastern Front added another layer of concern. Soviet pilots flying American Lend-Lease aircraft, including P-47s and P-39s, were outperforming German machines at medium altitude. The engineers in Rechlin began to grasp the larger truth. The war in the air was being won not by design brilliance alone, but by industry. The P-47 embodied that truth. It was a perfect marriage of engineering, resources, and manufacturing power. Germany, cut off from resources, bombed daily, and strangled by bureaucracy, could not hope to replicate that formula. The engineers submitted their final evaluation to Berlin. It was blunt. The P-47's engine was beyond current German production capability. Its materials, cooling systems, and turbo-supercharger technology were too advanced to copy under wartime conditions. They could imitate, perhaps, but not reproduce. The Luftwaffe command took note. By the end of 1944, focus shifted away from piston engine development to jet propulsion. The Me-262, the He-162, and other desperate wonder weapons. The piston war was lost. The captured P-47 had proved it.
As the Allies advanced into Germany in early 1945, the Rechlin testing grounds grew silent. Many of the engineers who had worked on the captured Thunderbolt were reassigned or evacuated. Some destroyed their notes to keep them from falling into enemy hands. Others simply walked away. When American troops arrived, they found what was left: fragments of test aircraft, torn notebooks, and a few surviving engines. Among them were traces of the very P-47 the Germans had studied so closely. Ironically, it was the Americans who ended up capturing their own plane back, now bearing Luftwaffe markings and test data in German handwriting. After the war, Allied intelligence launched Operation Lusty, a massive effort to seize all German aviation secrets. In the process, they uncovered documentation from Circus Rosarios, including reports on the captured Thunderbolt. The papers revealed in detail how deeply the Germans had studied the aircraft and how awed they were by it. In post-war interviews, surviving engineers admitted the truth. "We realized," one said, "that our designs were elegant but fragile. Theirs were brutal but brilliant." The P-47 Thunderbolt went on to become one of the most iconic aircraft of the war, a symbol of American industry and endurance. It was not the fastest or the prettiest, but it was unstoppable. It could dive faster than anything in the sky, shrug off damage that would tear other fighters apart, and deliver firepower with unmatched reliability. And deep within the ruins of a defeated Reich, the German engineers who once dissected it could only acknowledge what they had seen.
a machine so advanced in its simplicity, so perfect in its purpose, that it marked the moment Germany realized it could no longer win the war in the air.
In the end, the story of the captured P-47 is not just about a machine. It's about the collapse of an idea, the belief that precision alone could conquer mass, that craftsmanship could overcome industry. The German engineers examined the Thunderbolt expecting to find a trick, a secret they could copy. Instead, they found something far greater, a reflection of what their own nation had lost: resources, stability, and time. And so, as the war closed and the skies fell silent, one truth remained clear. The power of the Thunderbolt was not just in its engine, but in the world that built it.